But it's hot, hot enough for diamonds bigger than grizzly bears to form. It's big, bigger than Jupiter, and extremely close to its star, to the point that it's actually slowly evaporating. It's not your average gas giant, but what is going on with this planet? What's happening up there? Let's find out. This is HD 189,733b, an extremely hot gas giant around 63 light-years away from Earth. We know about this planet because in 2005, astronomers found it by looking at how its parent star's light changed when the planet passed between us and the star. It orbits this star, HD 189,733, every 2 days. That is incredibly fast and also extremely close to its star. The planet receives more than 100 times the amount of radiation from its star compared to Earth, and that's why the place is so freaking hot. The reason we know it's a gas giant is that it's roughly the size of Jupiter, but more massive. But this planet is not like Jupiter. No, no. There are some really weird things going on here. First off, the day side of the planet is 1000 degrees Celsius hotter than the night side. The average temperature on the day side is 1300 degrees Celsius. And even though the night side is still very hot at 300 degrees Celsius, that's still considered a relatively cool place on this planet. This dramatic difference in temperatures makes the atmosphere of this planet churn, with winds moving from the night side to the day side at a speed of up to 18,000 kilometers per hour. These strong winds are caused by the temperature gradient between the hot day side and the cooler night side. As the air on the night side cools, it becomes denser and sinks towards the equator. On the other side, the air on the day side expands as it heats up and rises towards the poles. Because of this effect, 18,000 km/h winds blow from the poles to the equator. To put this into perspective, if we were to experience these same speeds here on Earth, a car would be able to drive from New York all the way to Los Angeles in less than 30 seconds. Another strange thing going on here is that the planet seems to have rain. But what's raining on this planet is not water. It's iron bigger than grizzly bears. Yes, you heard me right. Iron bigger than grizzly bears. How do we know this? Well, in 2011, astronomers looked at the light filtering through the atmosphere of this planet, and since different chemicals absorb different wavelengths of light, they can tell what part of the light spectrum gets blocked, indicating that it was absorbed by certain chemicals. They found that the amount of sodium in the atmosphere is higher on the day side than the night side, which means that sodium condenses and rains on the day side where it's cooler. Sodium is a very important ingredient in the production of iron, so it's possible that this rain is made of pure iron. If you imagine the size of one of these iron droplets, it would be humongous. Since the pressure on the planet is thousands of times higher than the pressure we experience here on Earth, the iron condenses into gigantic drops, literally the size of cars or even bigger. They fall from the sky like meteor showers, bombarding the ground with molten iron bigger than grizzly bears. I already mentioned that this planet is very close to its star, and that another reason why this planet is so weird. You see, the gravity of this planet is around 25% stronger than the Earth's gravity. It's a bit unclear whether this is because the planet is more massive than Jupiter, or if it's because it's closer to its star. But whatever the reason is, this strong gravity causes iron to rain non-stop on the surface. So basically, there is an endless supply of iron on the surface of this planet. But what does this iron turn into? It turns into diamonds. Yes, you heard me right. Diamonds bigger than grizzly bears. The pressure and temperature on the surface of this planet are the perfect condition to produce the biggest diamonds in the universe. The only problem is that we can't get there to pick them up. Because of its extreme heat and the strong gravity, the atmosphere of this planet extends very far down. The atmospheric pressure is thousands of times higher than the Earth's pressure. At some point, the pressure and temperature become so high that the atmosphere turns into a liquid, and this is where the evaporation happens. The intense heat from the star evaporates the atmosphere of the planet. It's like boiling water, but instead of water, it's iron. The evaporated material forms a sort of exosphere around the planet. This exosphere extends hundreds of thousands of kilometers into space. It's a very thin atmosphere because otherwise it would have formed a thick cloud around the planet. The evaporated material creates a glowing cloud around the planet. This glowing cloud is not the same as the aurora we see here on Earth. Aurora on Earth occur when the Earth's magnetic field lines get disrupted by solar wind, causing charged particles to rain down on the poles. On this planet, the glowing cloud is created by the extreme heat and the evaporation of the atmosphere. But why haven't these aurora been observed before? This planet is pretty far away from Earth, and it's not easy to observe. It's also not particularly bright because it doesn't reflect much light from its star. It takes about 22 years for the planet to orbit its star once, so we don't know exactly what it looks like. But now, thanks to the Hubble telescope, we have the first ever image of this planet. Thanks to the improved technology, we can now image these planets because they are so far away. They looked like stars. So, to tell them apart, astronomers use coronagraphy to block the light coming from the star and reveal the planet. In the case of this planet, the image was taken in near-infrared light. Because visible light can't pass through the thick clouds and smoke surrounding the planet. And this is what we see. A small dot is the planet. It looks like a dark spot against the bright background of the star's corona. It's a weird-looking planet, and honestly, we don't know too much about it because it's very far away. But it's a great target for future telescopes like the James Webb Space Telescope. I think it goes without saying, but let me say it anyway. If you like optimistic science and tech stories, subscribe for more. Now back to HD 189733b. The thing is that this planet could have rings like Saturn. Astronomers think that based on the fact that when it passes between us and its star, something blocks the starlight for a few hours. They believe that it's probably a ring, but since we haven't seen it with our own eyes, we don't know exactly what it is. What we do know is that this planet has a moon. Scientists think it's around 10 times the size of Earth's moon, and it orbits the planet every 11 days. The moon is huge compared to the planet. It fills up half of the planet's sky. Every time the moon passes between the planet and the star, it blocks a tiny bit of starlight. The planet is already very hot, but this moon could be making it even hotter. Moons usually reflect light from their planet or their star, which makes them visible. If this moon is reflecting light from the planet, then it could be bombarding the already hot planet with even more heat. But on the other hand, maybe the moon is blocking some of the star's light from reaching the planet. So it might be making the planet cooler. So, who knows? Maybe the moon is the reason why this planet is so hot. Or maybe the moon is the reason why this planet isn't even hotter. And finally, the question everybody had in mind when they clicked on this video: can we mine diamonds from this planet? Well, unfortunately, the answer is no. There are a few reasons why. The main one being, well, it's just too far away. Even if we could send a spaceship there, it would take thousands of years to get there. And then when we get there, we would need a way to collect those diamonds. Remember that the planet's gravity is significantly higher than Earth's gravity. That means that the ship would need to be incredibly strong to withstand that force. Then we would need to land on the planet, which is completely covered in liquid iron. And then we would need to drill into the surface to reach the diamonds. I mean, yeah, it's theoretically possible, but it's just not practical. Sorry, what do you think? Did you like this video? If you did, leave a like. If you didn't, leave a dislike. Either way, thanks for watching. Subscribe for more videos like this one. And as always, have a great day.